In this example, we want to try to find the area of a polar region. This is a very popular question. They'll give us a rose curve and they'll ask us for the area of one of the petals of this rose curve. So our function is r equals 5 sine 3 theta. So the first thing we can do is we can go to our TI and we'll graph it. Okay, so we'll go in here, we'll go to y equals, we'll type in 5 sine 3 theta, we'll push graph. If you need to adjust the window, you can do that. So this is what our rose curve looks like. It's got 3 petals. That's actually due to the fact that we had the 3 theta as opposed to just a theta. So we want the area of one of these petals. It doesn't really matter which one. So let's come back over to our page here where we're working. So here I went ahead and sketched out what this guy looks like. And let's say we want to find the area of this petal. The 3 are symmetrical. They all have the same amount of area. So it doesn't really matter which one we use. So one of the biggest things we're going to have to decide is in this formula, which there is a formula for the area, the 1/2 integral alpha to beta function of theta squared d theta, where the function of theta is 5 sine 3 theta. The biggest thing we need to talk about is how do you find the starting point and the ending point for this region. The starting point starts right here, and granted that's the origin, but I don't really know the theta. The r is 0, but I don't know the theta, that this guy starts at. And then the r value goes out, and then it comes back to the origin. I need those 2 thetas. So I've got like a theta 1, like a starting value, that's my alpha, and then a theta 2, that's my ending value, which would be your beta. Now in the last video I gave a tip as to how you would find that. What you actually do is you take your function, your 5 sine 3 theta, and you set it equal to 0. So we'll take 5 sine 3 theta, we'll set this equal to 0, and then we'll try to just simply solve for theta. If we can solve for theta, we'll have our answer. So let's see if we can do this. All right, so step 1 to solve for theta, I think is pretty obvious. We divide by 5. So sine 3 theta equals 0. And then we have to think, okay, unit circle time. What angle, if we took the sine of it, would give you 0? And I can think of a couple. Sine of 0 is 0. Sine of pi is 0. 2 pi, 3 pi, 4 pi, 5 pi, negative pi, negative 2 pi. Any of those angles would give you, sine of those would give you 0. So what that tells me is that 3 theta needs to either be 0, or it needs to be pi, or it needs to be 2 pi, or it needs to be 3 pi, etc. 3 theta has to be one of these things. Now, that's not what theta is, though, but we can easily solve for theta. So if 3 theta has to be these things, then you tell me what's theta. Well, the theta, if we divided both sides by 3, would be 0, or pi over 3, or 2 pi over 3, or pi, etc. Those are the thetas that are going to make us come back to the origin, because that's going to make r equals 0. Any of these choices of theta here. Because when you triple them, you'll get 0, pi, 2 pi, 3 pi, and sine of all those are 0. And sure enough, if we look at the graph, all right, look at 0, yep, look at pi over 3, look at 2 pi over 3, look at pi, and you see, sure enough, those are the places that it comes back to the origin. Now, which of those would create region number 1 right here? Look at these angles here. I think if we start at 0 and we end at pi over 3, I think that's going to enclose the first region. And sure enough, look here. If you start at 0 and end at pi over 3, right here, I think that'll enclose that yellow petal that we've been looking for. All right, so here we go. So we have an area equals 1/2 integral from 0 to pi over 3 of 25, that's 5 squared, sine squared 3 theta d theta. If you really made me, if you told me I had to do this by hand, I could do it by hand. We could do a power reducing formula for sine squared and get an answer. But for most of these, most instructors are okay with just using a calculator here just to save some time. Even if they're sticklers about doing things by hand, this is one place where I think it would be acceptable to use the calculator. So let's go to our TI here, and we'll get out of this, and we'll do 1/2 times the integral from 0 to pi over 3. Just type this in verbatim, of 25 times the quantity sine 3 theta squared d theta. Make sure you typed it in correctly and all that good stuff. Push enter. You get an answer of 6.545 rounding. So we'll just say 6.54. And that will be approximately the area of that one petal, 6.54. So let's come back to our screen here. We have 6.54, and that's approximately the area of one petal. Now, just since we're done, just let me mention one quick thing before I let you go. Sometimes we'll be asked for the area of all 3 petals. No problem at all. You would just take this answer and triple it for the area of all 3 petals. Don't do the integral from like 0 to 2 pi or anything like that. You just want to do 1 petal and then multiply by however many petals that you have. So anyway, hopefully that example helps you understand finding the area of polar regions just a little bit better.